Next, we will discuss a DNAT. DNAT means a Destination Network Address Translation. D means destination, and rest of the thing we already know, NAT, Network Address Translation. So as the name suggests, Destination NAT means the destination address will be changed and the IP header of the packet. Or maybe the destination port will be changed and TCP UDP header, so we call them Destination NAT. Previously we discussed source address translation, the source was changing. Now in which situation we are using Destination NAT? When we have a server in our DMZ or maybe inside and somebody want to access them from outside, from internet, so in that case we need to configure Destination Network Address Translation. So it means a DNAT is performed on the incoming packet. So public address will be translated to private addresses. Previously in the source address translation, we translate private IP addresses to public IP addresses. But in the case of Destination NAT, we will translate public addresses to private addresses, so we call them Destination NAT. Also in this Destination NAT, we can do few more things as well, such as port forwarding, port translation as well. And as I say, we use Destination NAT in the case of we have a web server or any other server which is hosted in our data center DMZ, and somebody from the internet want to access them. So in that case, we need to configure Destination NAT. So if I go to our topology, in this case, I have a two server 1 and server 2. So in that case, we need to configure Destination NAT. So somebody from the internet, they can access these server. So if I go to HQ firewall, so we already configure two Destination NAT. Okay, just to show you. So I say somebody will try from WAN 1. They will hit WAN 1 because why I put both this one. So what is this area for us? This is our WAN area. So somebody from WAN will hit our WAN. And when it's hit WAN, so it will be translated to the server. So that's why I put here that the source is WAN and the destination is also WAN. The source can be anybody from the internet. And if somebody hit our public IP 192.168.1.50, so translate that IP, I'm not using source, I'm using destination. Translate that IP to server 1. And server 1 is basically our this one 10.0.4.1. So this is a Destination NAT. Similarly, we configure another destination and we say if somebody try from internet and hit our internet interface, okay, and the sources can be anybody, and if they hit our public IP 1.60 as per our lab, so translate there to 10.0.5.2, which is 10.0.5.2, this one. So you get the idea, yeah? So in this case, we need to configure Destination NAT. Now, if we come here and go here, so we have a Destination NAT static IP and dynamic IP. Also with static IP, we have here translated port. So translated port, it can be port forwarding or it can be port translation. So static are with two option and dynamic with also with option translated port. So even though Destination NAT has two type, static and dynamic, however with static we have an option of port forwarding and port translation, and also with dynamic IP we have an option with port translation and port forwarding. You get the idea? So let's go to discuss those Destination NAT option. So the first one is static IP, which right now we have configured. Static IP is statically allocated. So 1.50 is allocated specially for this server 1. And similarly, if I go here and check here, So 10.0.5.2, which is our server 2. So here the public IP 192.168.1.60 is statically assigned to this server. So in this case, we call them static IP, but this is a destination NAT. So use static IP to change destination IP address while leaving destination port unchanged. We will not change any destination port. Statically translate original destination address to the same translated destination address all the time. So single destination IP address or range of IP address or list we can use. Original packet can be. What does it mean? I will explain you. So static IP, what I have done here, I have configured, let's see, 1.60. So if somebody try from outside internet, let's go to web browser, and here let me type 192.168.1.50. So you can see it's hit our server 1, this one. And if I type 1.60, let me type 1.60, so it hit server 2, but no port translation, original everything. So this is static IP. Why is hitting? Because we have configured two destination NAT. We say if the original packet means the source is this one. If somebody try from internet and they hit our internet interface, because the traffic will come here and they will hit our internet interface, okay, and it can be anybody's source address. Whenever they hit 1.50, which is our WAN range IP, when somebody hit 1.50, kindly firewall translate that with destination address. So the destination will be changed statically to server 1 without any port translation or anything. You get the idea? So we can go to monitor and we can see we send those hits. And if you go to session browse, so from here, let's verify. Let me generate some traffic again. Okay, and let's see now. Yeah, so from when one somebody hit DMZ, this was the public IP, somebody from this source, and they hit our 1.60. So here we have, this is a public IP, somebody hit our public IP 1.60. So what we done? So we translate this destination. You see, source is the same. If you check here, the source is the same, but we change the destination. Okay, so 1.60 is being translated to 10.0. Or we can verify here more clearly if you go to secure CRT, and let me open my firewall. Okay, if I have here, let me log in here, admin. Okay, and from here I can type show session all. So you will see destination net here is N means network address translation and D means destination. Previously it was S. Okay, and this is the you can see this was the public IP somebody try. Okay, and the destination is being changed and they hit our this IP. So we change that destination IP to this IP 5.2 server 2. You get the idea? So this is called destination NAT. We can verify here as well, or we can verify here and we can capture a packet to see as well. So this was the first type of destination NAT, which is static IP. Statically, we just change the destination IP. How we change it? So let me show you from here as well. So what I done here, this is one external system anywhere on the internet, and they hit here 1.50 and 60. Okay, so when they hit, so this is the destination, yeah, for this user. So we change this destination to this IP, and when they hit 1.60, so we change that to server 2. So which thing has been changed? The source is the same. We change the destination. When they hit 1.50, 1.60, so we change that to these IPs. So that's why we call them destination NAT. And statically, two different IPs are assigned to these two servers. So that's why we call them static IP destination NAT. Okay. Let's go to the second one is port forwarding. We can forward the port as well. The same port or the different port, we can forward them. But normally when we keep the same port, so if I go to network and the policies and go to network and let's go to the first server. So if somebody from internet and hit our internet destination zone, their source can anybody 1.50 somebody hit. So we will translate them to, by the way, this is 10.0.4.1. Okay. But I just create a what is called object 10.0.4.1. So what to do? If the port is 80 and we have a port 80 as well, and click OK and click commit. So now we are forwarding the port as well. Okay, let me clear this one and show session all. Okay, right now we don't have anything because no hits. So keep in mind there is nothing yet. So then we will try that one. So after that, what we done, port forwarding can translate public destination address and port number to private destination address. So then we call them port forwarding. Techniques to use manage traffic through NAT policy based on destination port number. So this time we change the destination port as well. And single IP address to multiple private server and services. This is different thing. So destination port can stay the same. This is important. Destination port can the same or it can be different destination port. However, in this case, what I done, I keep the same port. The server is also configured on port 80 and I'm also translating to port 80. So this is called port forwarding. Yeah, I save. So now if I go back to external, okay, because I changed for 50 only. So let me hit this one few times. And now we can check the session here. So let me clear, and so here you will see a lot of things. Let's see, not this one. Yeah, it's this one. Okay. So this is the ID. ID is which one? Let's see. We can see this ID in more detail. Let me see if we can ID, and the ID number is this one. So this is in more detail. Okay. So here we say that the source was this one and they hit this 1.50 IP, which is on the external interface. Okay, what we done, and now let's go back, and destination port is port 80. This is the second flow. So what we done, the source will be the same. Okay, they change this to, we need to check the second flow. So what they will do, they will change the destination. 1.50 will be translated to 10.0.4.1. However, the source, which was this one, okay, because this is this type flow, but just to show you. Okay, and these are the thing. So they hit our rule, this one, because we just create this rule. So you can see they hit this rule. Okay, this why is showing us internet to DMZ. Okay, this is the reverse one. And we have this one, destination net to web. So we can verify from here as well. You can see that one. Okay. And also if we go back and let's go to our firewall and go to monitor, and here is, so 10.0.5.1. Okay. I need to hit this one. It's the correct one. It's here. Okay. So this was the source and they hit 1.50. Okay. So we change the destination to 10.0.4.1. Okay, so because the destination is changed, and this time we change the port as well. Okay, so this is called port forwarding. So we can do port forwarding as well. Similarly, we have an option of port translation. Port translation means maybe the server are configured on some other port. So our web server is configured on port 80. Can we do something else? Yes, we can do. If we go back, okay, and here we can say port 8080. So if somebody this should be 80, and original, here I can say services. Okay, I can create a new services port 8080. So you can make them that one as well, but it's okay, it's any. So if somebody hit 8080, so translate them to what is called this port 80. Okay, so even we can try that one by port 8080 as well. Okay, but for that we need to change this original packet, that if the services is 8080 and somebody hit 8080, so what to do, translate them to 80. So this is port a translation, which we will do later on, but just so that you can understand. So we have a port translation as well, and we have port forwarding as well. We can forward the same port. It's almost the same concept. So real port number and private, change the destination port. Okay, so maybe your web server is listening on port 8080, but the public internet IP will hit on port 80. So now you are hiding the port as well. So port translation, nobody know the real port is configured on the server. But if they try the normal port, suppose port 80, however, our original server is configured on port 8080. Or it can be reverse. Maybe somebody will hit on port 8080, but we will forward them to port 80. So this type of destination NAT is called port translation. And finally, we have dynamic IP. If we go back, and here is the second option, dynamic IP with session distribution. Session distribution, okay, so I choose that one. Now with session distribution, we have multiple options. By the way, let's discuss dynamic IP. So if the original destination is one IP address and the packet from the internet outside, need to translate them to multiple destination IP, which we have internal server. So means one outside IP map to multiple inside IP addresses. It's like a load balancing on the servers. So then we can use dynamic IP. What does it mean? Suppose I have two servers. Okay, so what I can do, I can choose dynamic IP. Here I will create a server pool object. So let's go to object, and here I have addresses object, server 1, which is 10.0.4.1, which is this one, and server 2 10.0.5.2, and I will make a group for these two, which is server 1 and server 2. Okay, and now I will go to policies. Okay, and what I will do, from destination to web server. Okay, I think so we have this one. Yeah, so what I will do, I will say that a dynamic IP with session distribution, distribute the session with these two server. In my case, I have two server. I give them a name DMZ server, where I have 10.0.4.1 and 10.0.5.2. Okay, and keep the translated port the same. And here is, we have different option in dynamic. Let's first do this one, then I will come to here. So this is called what is called, and the IP address, by the way, I configure somebody hit, which is 1.90. So let me quickly show you from outside. If try 1.90, okay, so it's going to server 1, refresh them. It will go to server 2 now. It was server 1, server 2, server 1, server 2. Because we have configured two server, it can be multiple server. So it's like a load balancing. So when the firewall somebody hit with the public IP, so the destination will be changed to 10.0.4.1 and 10.0.5.2. And because here what we decide, that original packet is this one. If somebody from the internet, they hit our internet zone, and this is our interface for any services, and anybody, they hit 1.90, translate that dynamically with session distribution and distribute the session dynamically. So we have a DMZ2 server. I create a group. Okay, and what I say, distribute them to both and use the session distribution method. Now this is the question. So round robin means it will go to one and then second. Here I mentioned rotating order. And that's why when somebody try to hit this one, so it will go to server 1, then server 2, server 1, server 2. So it's rotating because I am using a round robin, which is the default one. Then we can choose source IP hash. Base of the source IP, it will assign them one of the server. Okay, so here is source IP hash. So based on the source IP address, it will assign them one server. Then we have IP modulo. Okay, what they will do, the firewall will perform XR operation, and they will do the source and destination IP from the incoming packet, and they will perform XR operation. Okay, and after that they will assign them one address to either the server to hit that one. Similarly, we have IP hash. So assign new session based on the source and destination IP address. So they will decide what is the source, what is the destination IP, and based on that they will assign them a session. And last one is lease session. So lease session means they will check which server has lease connection. They will assign them that server. Suppose in our case, suppose server 1 is too much busy and we are using the option lease session. So they will assign them to this server 2. They will send the traffic to server 2 because they have too much session and this one is less session. So we have these options in dynamic IP. So I hope so you get the idea that what is dynamic IP in destination NAT. Okay, if we have multiple destination IP and tunnel server, if you want to load balancing like that concept, just for understanding purpose. And then we have different option: round robin, source IP hash, lease session, IP modulo. You can use different option, which one you want to translate them and to use that option. So this is dynamic IP. Then we discuss port translation and port forwarding, which provide by static IP. So static IP we saw, we create separately for each server separate static IP. Okay, when somebody hit that one, it will go to that server. However, you can port forwarding, you can forward the port, either you can translate the port as well. So this was all about destination NAT.